Welcome to UET's single-phase extraction presentation. This technical presentation will provide you with what the system is about and the reason why it is the most cost-effective and quickest way of recovering LNAPs from a spill. This presentation is split up into three parts. Section A will discuss what UET's SPE system is made of as far as components are concerned. Section B will provide the reasons why UET's single-phase extraction system is the most cost-effective and quickest way of recovering LNAP. Section C will provide you with reasons why a pilot pump test is necessary to define the LNAP problem so that an optimized recovery can be made. Oh, shit. This is our block diagram of the entire system. It's made up of 5 components. One is the system control panel, the SCP, which is extremely important. It is the control system, as it's indicated. That's where the remote monitoring takes place. That's where the data is stored as far as the recovery operations are going. And it can send signals to the other 4 components as required. The vacuum pressure system supplies the energy that brings the product from the saturated zone into the well. The size of the vacuum manifold is dependent on the number of wells. This particular example shows 6 wells being employed in the recovery of LNAP. Of course, you have a recovery tank, which is just, it could be multiple recovery tanks. It could be a big 20,000 gallon tank. And finally, the downwell unit, which is an extremely important part of the system. That's what goes into the well. And then it can go into anywhere from 2 to 4 to 6 or bigger well. Now, a little bit more detail on the on the system control panel. It controls the operation of, I said before, the SPE system. It allows an adjustment for site-specific conditions. It provides interactive remote monitoring and control. It also provides system operational status, alarms and faults. And it provides for an analysis of system performance data that will allow you to adjust the system to optimize recovery. Here's the downwell unit, as we said, is a very important part. It is made up of a footpiece section, which is at the bottom of the unit. There is a sensor at the top of the footpiece, and that sensor will determine whether the liquid being recovered is water or product. If it's product, it will go on through into the product canister, where it will be accumulated until a product sensor indicates that it's full, and then pressure will be applied to push the product to a recovery tank. The size of the footpiece is dependent on how much of a drawdown, and the size of the well. The vacuum is applied, and it will bring the liquid up into the foot pieces, and where it will be determined to be product of water. The vacuum pressure system is very important. That's where the energy is generated, and that's supplies the vacuum to the downwell unit to influence the plume that's located in the saturated zone. So it is a modular design, and it allows the vacuum to supply to be increased as required. It will provide the differential pressure that's going to be required to move the product toward the recovery well. And the vacuum pump, of course, will be determined by, I should say, the vacuum pump and tank will be determined, size will be determined by the number of wells you're pumping, how big the wells are, and other factors. Here is the picture of a manifold, and that's simply the pressure vacuum distribution to the recovery well. In this particular site, there were 6 of them being operated, and that's why you have 6 legs. Recovery tank is a variable depending on what the site conditions are, the recovery rate, and what there's whether you have multiple ones. It's a specific design, and it might also include an existing tank that's on the site. A product sensor, however, will be located in every recovery tank, to make sure that we do not over pump the tank. That's section A. Now we're into section B. Section B is about why our system is the best system to recover El Napo. There are really 2 steps to recovering product. Step one, obviously, is you got to bring it into the well, and step 2 is you can remove it from the well. The hard part is step 1. That is done with a lot of energy. The more energy you have, the more product will be brought into the well. We follow Darcy's law, and when all is said and done, you need to have maximize the gradient, which is the differential pressure caused by the vacuum, and you need to maintain that, and you need to operate 24/7 to maximize the recovery. Bigger wells with more open area in the screen will be a positive factor. The important point here is that really of all the systems, SPE and MPDPE systems meet this first requirement. In other words, they're pumping all the time, and they're high vacuum. A vac truck doesn't pump 24/7, and because it doesn't pump 24/7, it'll be not the most effective way of recovering El Napo spill in any time soon. The important thing is that step 2 is, what do you get out of the well? You get product and water with a MPE system or a vac truck, and you have to separate this above ground That's a very expensive process. And the SPE system, or UET's SPE system, will remove the product without water, which will reduce the cost of the cleanup uh, a great deal. Here's a comparison of all systems that are out there. We have our SPE, we have passive systems. It's any system that basically removes product from the well, but doesn't remove it. It doesn't really have a lot of power. And the vac truck that we talked about before, and MPE, DPE systems. So going through it, you can see that step one, UET, yes, passive systems, no, and vac trucks and MPE, DPE systems, yes. Step two, they all do that. That's not a problem. 24/7 operation, the SPE system and an MPE, DPE system meet that criteria. LNAPL product only the UET system, our SPE system meets that requirement. And as far as groundwater treatment and required, we don't require it. All the other systems do. UET's SPE LNAPL system recovery system, excuse me, will achieve no further action faster than any other system. Why? Well, we have the high vacuum, 20 inches of mercury. That's going to maximize the mobilization and the amount of product that moves into the well. We don't pump water. That's going to be a very, you don't have to discharge, and we don't have to separate it. We don't have to any of that. And the interactive monitoring allows us to know how the system is operating and whether or not adjustments are needed. And by maximizing the amount of time you're applying basically the vacuum to the saturated zone is very important. That's not done with MPE, DPE systems. It's not done with a vac truck. Our remote monitoring is an important factor. It really allows us to immediately determine whether there are some operational problems, and we can fix most of these problems online. It allows system adjustments. Data is very important, and seeing whether your current operation is optimizing the recovery. If it isn't, changes can be made to do that. Excuse me. Section B, also in this UET's system, versus skimmers. We've already kind of talked about that. But here's a real live example. Here's a place where, here's an example of our system working in a well in which a skimmer had been operating for 356 days. We operated for only 4 hours. In the 356 days, the skimmer recovered about 122 gallons of product. In 4 hours, we recovered 21. That gets projected to, you can see, we are talking 143 gallons per day at that rate, or 1,000 gallons per week, compared to the skimmer, which is less than a gallon per day, and a little over 2 gallons a week. Here's another example of where we have we can excel. Here is a MPE DPE system, and it shows one of our SPE systems. I'm not presuming that our SPE system is recovering from, it's only recovering from 3 wells as opposed to maybe 25 or 26 wells. However, it's more effective, and you can see the difference in the cost. We provide a more surgical approach to it rather than a mass force, which is expensive and also ineffective sometimes. Another example of why our system is a very important, it can pump any type of immiscible liquid. It can pump number 6 oil. You know, a MPE DP system is going to have trouble doing that. It's not going to be very effective. And a vac truck is going to pump, it has the energy to pump number 6 oil, but it's too viscous for it. It's unless there was some way to heat this stuff, you wouldn't be able to really do it with a vac truck as well. Now, we talked about a pilot pump test. It's a very important part of any problem, is to understand the problem before you start solving it. By doing a pilot pump test, you really do that. There really are 2 types of data. Existing site data, you know, you have a site plan, you go out and you make gauging measurements of the various wells, you see how much product that's in these wells and so forth. Well, that's all sort of static, and you see it from time to time, but what is needed is something that's going to, testing that's going to provide you with dynamic site data that's going to really tell you how it's going to work when you start pumping. So what we do is we provide a pilot pump test, which could be anywhere from a day to 2 days or longer if required. And it will do 3 basic things. It will tell you how much product you have recovered. It'll give you actual numbers over a period of time, and that can be extrapolated to see what that would be for the specific pumping well with the right conditions. It establishes the radius of influence. So you know, by doing that, well, I can probably recover this. I got to put another unit in another well because it's too far away. And it also will, in certain cases, provide you with a aerial dimension correction. Usually product plumes are delineated by simply where the product is, but you don't see really what's beyond the well. You make assumptions. This will give you actual indications as to how much lies beyond the well, and that can be that can personalize the plume. Excuse me. Now we've gone through this presentation, and there's a lot of information. Here are the numbers to call for if you have a question or would like an answer on anything. You have the option of calling our phone or sending us an email, and that information is right there. And you also can go into our website and get additional information. That concludes the presentation. We hope to hear from you.